Hi, Alan Rushforth here. I'm a structural engineer in the Philadelphia area, and I'm trying to put together right now this little informal instructional video on concrete block foundation walls and options for, if they're cracking, options for dealing with them. So let's jump right in. Here's a section through the concrete block wall, footing, basement slab, floor joists above. And we have soil pressure on that wall. I'm wondering if anybody notices a grading problem here. Okay, I run into this occasionally where the grading is right up to where the wood plate is, or even piled up, mulch and soil piled up against the siding. Terrible situation, asking for rot and termite problems. Okay, by code, the grade should be 8 inches below the top of the block, and pitching away 6 inches over the first 10 feet. And of course you want that pitch to continue. You don't want a lake forming out here. That's a grading issue which should be corrected, even if it's going to be at significant expense. That's fairly important to have that graded away from the house and several inches below the plate. 8 inches ideally or more. We have soil pressure on the wall. Now it's interesting, I have heard contractors say, well, if you put in the weep holes in a drainage system on retaining walls or in various situations, that alleviates all the pressure, you'll have no problems. Well, there is a soil pressure component that stays there even if you have solved the hydrostatic component. So it is important to relieve the hydrostatic pressure, but you also have to provide for resisting the soil pressures. Okay. And that soil will be pushing on the wall, and it will tend to open, as this wall pushes inward, it will tend to open up hairline cracks in the wall, horizontal hairline cracking that with time may turn into a situation, a more severe situation like this. Larger cracks, 2-3 inches of bowing in the wall, and even sliding at the bottom. And if you have proper rebar enforcement installed, per modern codes, you're probably not going to run into that. But a lot of the older walls, maybe they didn't have that done properly or not done at all. So this is what you can run into. I'm actually sort of a little more interested in this preventive maintenance thing because I have a new approach I want to show here, or a little bit new. But we'll just spend a couple minutes on this type of more severe problem and what could be done about it. You're probably going to bring in a structural engineer if you are dealing with this more severe problem, and probably what's going to happen is this would get shored up, okay, excavated back here, and depending on how severe the problem is, this may get removed and rebuilt. Okay, when it's rebuilt with the proper rebar in the wall, running vertically every couple feet or so. Another approach, if it is, maybe you have significant bowing, significant cracking here, cracks are open, they have not been mortared in or caulked in, and maybe it hasn't slid at the bottom, maybe that's still intact, more like over here, okay, but just greater bowing. If one excavates behind, one may be able to actually straighten that wall out just by a couple guys pushing on it, as long as there's no soil behind. It may even straighten out by itself without pushing on, just from the weight of the building. Okay, so if that happens, you can possibly reuse this wall. Okay, but you would still want to reinforce it. Ways to reinforce it would be chop holes in the concrete cores, like every couple feet. Insert rebar down, should go all the way down in that bottom course. Insert rebar up. They should lap a good foot. Okay, wire tie them. And then chop more holes in the top, fill these cores with poured concrete. Okay, that will lock that rebar into place. You fill the core where the rebar is every couple feet or so. Okay. Another approach, third approach, would be, aside from rebuilding or adding rebar into the core, would be soldier beams in front of the wall. Okay, possibly you can get this wall straightened out. Maybe 4-inch I-beams, okay, with blocking at the top, at the bottom. Break the concrete floor away and embed that into the floor, re-concrete with 4 inches of concrete up against the I-beam. probably like a 4-inch I-beam, section modulus 3 or greater, or bigger than that, to be specified by your engineer. And if the wall is higher than 8 feet, then it probably could be, would be bigger than that. So that's on this more severe problem. But let's take a look at these more minor problems and what preventive maintenance can be done. And maybe you can do some of this preventive maintenance yourself or with your handyman contractor without really needing to bring in an engineer, before it gets to this kind of severe situation. So I have 3 little bullet points down here. First one, correct the grading, pitch it away. If you have tree roots pushing on the wall, get rid of the tree. Overflowing gutters, creating ponding here, again, fix the gutters, fix the ponding. If you just have minor hairline cracking, that may be enough to solve your problem, and then monitor it. Make sure it doesn't get worse. If you want to be more proactive, I have 2 approaches down here, carbon fiber strips and fiberglass mesh. The carbon fiber is fairly well accepted in the foundation repair industry. Fiberglass mesh, I haven't really seen that, although it's used a lot in all kinds of applications. Here's tile backer board, okay, with fiberglass mesh on either side. I haven't actually seen it used in this kind of reinforcing of foundation walls, okay? So that would, I've actually done a little study on how that could be adhered, what weight mesh and what type of forces it would have to withstand. And we'll get to that real quickly. I'm just going to talk about carbon fiber a little bit first, because that is the little more commonly accepted method. Here's a roll of 12-inch wide carbon fiber. I used maybe a third of this on a couple projects on some of our rental properties, so I have a little first-hand experience with it. It gets adhered with epoxy. It goes on in strips. It's expensive enough. You don't want to cover the entire wall. You're generally going to put like a strip of that on about every 4 feet. The kit I ordered from, it was bestmaterials.com. That was about the best source I could find. Was $1,000 for 100 lineal feet, which and a few gallons of the epoxy. That would be enough for roughly 50 feet of basement wall to put these strips every 4 feet. One other extra issue to mention on carbon fiber, since it's going on in strips, you have a bit of a stress concentration where every strip is going. The manufacturer wants to see excellent adhesion there with the concrete. They are recommending grinding the wall, okay, with a diamond grinder, something like, it could be like this with a shroud on it, okay? And you would need a good vacuum setup. Shop vacs are going to tend to clog right up pretty quickly. I found a little Dyson canister vac can work well on that. But basically the dust is potentially carcinogenic, so that's an issue to keep in mind. It's sort of getting out of the category that, most handyman are going to have a little problem handling that kind of thing. It gets into a specialty item. The costs can be jacked up because it's structural and it's specialty. Okay, so I'm wondering, are there less expensive alternatives than this very fancy carbon fiber, which is, it's like great on race cars and racing bicycle frames, and where you really need high strength and lightweight. But on a foundation wall, it doesn't matter if what we put on there weighs a few hundred pounds. It's we just need it to be practical. It's got to be strong. It's got to hold up over the years and not cost an arm and a leg. So let's take a little look at fiberglass. And for starters, I want to quantify the number a little bit in case there's any engineers watching. And if you're just a homeowner or whatever, don't worry too much about the numbers at this point. But I did some calcs on the soil pressure here, and just trying to get in what ballpark are we looking at in terms of what force, tensile force, will be applied to whatever reinforcement we put on. Let's say it's a 1 foot thick wall, 8 foot high, as the soil is pressing on that wall. Okay, and I came up with about 1,500 pounds of tension for every lineal foot, okay, of wall. As the the soil forces are trying to move this wall into that. You know, it's got to be stopped. Okay, so look, we're looking at like 1,500 pounds. So this is what I calculated, 1,500 pounds, and that's pretty rough. Okay, so what I'm going to do is just double that, so to create a little margin of error. If the soil is a little different than what I figured on, or maybe you do have a little if you have a lot of hydrostatic pressure, you'd want to even go higher in this, but I doubled it, 3,000. Okay, so I tested carbon fiber, and I did little strips. You know, I didn't create big wall areas, but 20-inch long blocks of wood. One can calculate the mechanical advantage. In this case, I did a 1/2-inch wide strip, which I would compare to 2-inch wide strips of mesh, because here we're doing 25% coverage with carbon fiber. With the mesh, we're doing 100% coverage. So I'm doing 4 times the width and trying to compare apples to apples. So carbon fiber, I'm getting, when it's 25% coverage, 3,000 pounds of strength per lineal foot. Full coverage on 4.5 ounce mesh. This is this IFIS mesh. IFIS stands for External Insulation Finish System. This is available from commercial supply houses that sell stucco materials, not Home Depot. This is commercial stucco that you will find used on shopping centers and office buildings, that sort of thing. And it goes on very thin, generally on top of a foam substrate, with a very high strength mortar, specialty mortar they call base coat, and then different weights of this mesh. This is 4.5 ounce, which is the most common, readily available mesh from these supply houses, and they sell heavier grades. This is 20 ounce. Okay, it's about the thickest grade I could find. Comes in 3-foot wide rolls. It's just a little 2-inch strip I cut off. So I did tests, and we have one layer of 4.5 ounce embedded in thin set or embedded in base coat. And a word on you know, what to embed this in. I'm trying out 2 things, which is base coat from the IFIS industry, where they sell specifically for embedding that mesh, and then thin set, which is from the tile setting industry, which is available at places like Home Depot. I'm suggesting using the more expensive acrylic fortified thin set, which is more like $30 a bag, a 50-pound bag, versus $10 50-pound bag. So, you know, we're using the good stuff, and actually both the thin set and that acrylic, the acrylic fortified thin set and the base coat, they're both very high strength fortified mortars made for adhering, and they both work very well with this adhering that 4.5 ounce mesh or any of these fiberglass meshes. Not too much difference between the two of them in terms of adhesion qualities. However, thin set you can get in white. Okay, so when you're doing 100% coverage, if you buy the white material, you end up with a white sort of semi-finished wall. So, and then I tried some heavier meshes, and really what starts failing is not the mesh, the bonding of it to the base coat starts failing. So I actually got the same strength, because you hit that limitation of how strong the bond is with the thin set. And here's what I found is like what I'm considering sort of optimal. 3 layers, even 2 layers. I didn't test that, but you know, 3 layers gives us wonderful 5,100 rating, which is way more than the 1,500 calculated, and even more than our 3,000, which allows a little bit of a buffer on there. So 5,100 with 3 layers, and I'm suggesting that that can be a viable approach for preventive maintenance on these type of concrete block walls that are starting to develop hairline cracks, but have not bowed out significantly. You know, if there is any bowing, it's very minor bowing, like less than an inch of bowing. So it's still pretty sound wall, but we just don't want it to get any worse. And what I would actually recommend is 1 layer run horizontally, 3-foot wide mesh, okay, right in the middle zone where the cracks tend to appear the most. And then 2 more layers run vertically, so you have a double layer, triple layer in the middle zone, double layer. And I think that is like very efficient use of materials to really strengthen that wall and sort of halt any movement and preventing it from getting like this. So I hope that's been helpful information. You've been such a good audience. We now have a bonus feature for you. We have two mock-ups here, wall mock-ups that we're going to test and destroy, at least one of them. So what we have here, this is concrete block, two pieces joined together, reinforced with a 1-inch strip of carbon fiber on it, just shy of 4 inches. It's actually a hair over 1 inch, and just dab of glue at the back to hold it while I'm keep it together while I'm moving it around. And this gives you that 25% coverage, which you would get if you put the carbon fiber on in 1 foot of strip every 4 feet. And here we have two pieces of concrete block that are reinforced together with 3 layers of 4.5 ounce IFAS mesh, fiberglass mesh, adhered with acrylic fortified white thin set. Actually, the green and white bag over there, VersaBond, is the brand from Home Depot, 30 bucks a bag. Okay, so what we're going to do on both of these is we are going to simulate the conditions in the basement where it's supported at either end, and then you have the soil pushing on it in the back, creating tension here against your reinforcing. And here's how we're going to do it, right here on the floor. And the carbon fiber, I'm retesting, I think I mentioned before, like 3,000 I was getting. That might be a little generous, might be more like 2,500. But I'm going to start testing it here if it worked out with spanning this much, with 200 pounds of load in the middle, which will be me. It creates 2,000 pounds roughly of, there we go, 2,000 pounds per lineal foot of tension. Now, increasing the span end to end, we're going to have 2,500 pounds of tension. It may break at this. Let's see if it holds. It's holding. Ah, it broke. Okay, 2,500 broke. How about that? Now we're going to test this bad boy here. This is 3 layers, which my tests are showing this is about twice as strong and less money. Okay, and it looks better. So here, let's start out. Here's a 2,500, no problem at all. Okay, let's go with another 50 pounds load on here. This gives us the equivalent of 3,100 pounds of tension on here. It's doing it, 3,100. This is going to be hard to balance. 3,700 pounds, that's about as high as I can go on this. Let's see if I can balance on here. 3,700 pounds. There we go, there we go. And we're not even able to break this, okay? We need 2 of me on there to break it. So that is pretty darn impressive, I think. It hasn't cracked. This is about a 32nd of an inch of fairly low-cost materials. So I'm going to give one more tip on application of this, in case any homeowners want to do this themselves, or for your contractor, he may choose to view this. With thin set, anybody who's done a bunch of tile setting, they know it's recommended you apply it, you scrape it off, and you reapply it. And what that does is it works it into the pores of the concrete. And then you would put your first layer of mesh on. I'm going to recommend running it horizontally across the wall, 3-foot roll, in the zone where you have the most stress. Then work that in, and then repeat the process. And then run strips vertically, 2 layers, bed it in, smooth it out. When you're all done, you end up with this nice smooth white finish, thin, strong, and you have added substantial reinforcement to your wall. And again, this is for situations where your wall is pretty straight, minimal, hairline cracks developing here and there. Maybe, whatever bowing, it's less than 1 inch of bowing, and you want to keep it that way, okay? If you have more serious bowing, bigger cracks, sliding, you're going to have to resort to more drastic measures and bring in your engineer. But this is, I think, an excellent preventive maintenance approach, and I hope that can be helpful to some homeowners and their contractors. And my goal is accomplished here.